got to this computer. Okay, yeah. So let's go to the Azure portal and start trying logging in SNIT tech.
Someone said screen.
Yeah.
Sir, you can't. He was not sharing the screen.
Yeah. Okay. So let me start sharing my screen. You able to see the screen now?
Yes, sir. Thank you.
Yeah. Yeah. So I'm trying to log into the portal. So today we are going to do a demo about load balancer. Load balancer is nothing but depending upon the load, it tries to load balance between the virtual machines within the backend pool, right? So let me try logging in. So the prerequisites for a load balancer. One second. What happened to this account? Let me try logging in with this account and see if it is working. Here, screen sharing has stopped. Share your screen and then screen 2. Okay. Able to see my screen now?
Yeah, yes, sir.
Yeah. Portal.azure.com and then we'll try to log into this. So it is asking for authentication because I asked not to ask for this multi-factor authentication for a month. So did you complete the labs from yesterday, creating a virtual network gateway and trying to connect 2 sites with virtual network gateway? Hello.
Yes, sir.
We have logged into our account and now let's try to quickly configure a load balancer. So for creating a load balancer, we have already created a LB SNIT load balancer yesterday. So in order to set up virtual machines into this load balancer, we have to create 2 virtual machines, right? So let's go ahead and create 2 virtual machines and source group. I'll be keeping that in. So this is LB1. So this is the first virtual machine, LB1 VM, and then I'll be creating this in East-US 2016 data center. Select size. Okay, I think we don't have sizes in East-US. Let's try to select East-US 2, or let's check East-US 2. Yeah, East-US 2 should be fine. So I'll be selecting a B4MS. Okay, and then I'll give the username. And password. and these virtual machines should be in a availability set. So that is what we have to create now. So there is no availability set. So let's try to create an availability set. Name av set SNIT, and then I'm creating 2 fault domains and 5 update domains. I'm clicking yes. So av set SNIT, I'm configuring this virtual machine in that availability set. Okay, yeah, click next. Disk SSD 3389, next. Tags, then review and create. Okay, before creating the other virtual machines, let me go to the virtual machines and let me clean up these 3 machines because I don't need them anymore, right? Let me go to these 3 machines and delete them because it consumes a lot of resources, right? And it consumes money as well. So that's the reason I'm trying to delete them. And let's see how the deployment is. And for a load balancer to load balance, we need 2 machines, right? Let's create one more machine, which is load balance 2, retrial SNIT, and then let me create LB2 VM. Okay, this is the second virtual machine. So let's go to East US2 and change that to V4MS. Select, and this is Windows 2016 data center. Click next, next, and review and create. So I'm just validation. So this is getting deployed. Let me go to virtual machines. These are, let this get deleted so that we'll get cores in this region and then we'll try to deploy that. Okay, so deployment is completed for LB1 VM, and West US new VM is getting deleted. Let it get deleted and then we'll try to create new VM.
Can't we create multiple virtual machines here, sir?
Yeah, we can create, but according to our free license, we only have certain cores in that region, right? Certain limit of cores. So if you already have reached the core limit, you may not be able to create new virtual machines. For increasing the core limit, you have to contact Microsoft so that they can increase the core limit from the backend.
Okay.
So if you see this error message, which we got, where is it? It is talking about the core limit because whatever the new virtual machine we tried to create, we asked for 4 cores, right? 4 cores are not available in this region. Is that? So that's the reason why it is giving us the warning message. Yeah. In the meanwhile, let's try to connect to our new machine. So this is our new machine. So let's try to install a simple web service on this IIS service. Okay, let's go to server manager. Server manager is opening up on this machine. Let's see if that machine is deleted, and let's try to create a new VM. New VM. This is LB2 VM. That is the second VM in that location, and I'll be selecting the availability set, AV set, and then 2016 data center change. I'm going to select B4MS. Okay, click next, review, and create. These QoS, it only have 2 core limit. So what we'll do, we'll try to reduce the core limit count on this. Okay, and let's try to set it for B2MS, because we only have 4 cores, right? So that's the reason we'll try to set it for 2 cores and 8 GB RAM. So this is 2 cores. Let's try to add a new virtual machine. And this will be VM2 East US2 availability set, AV set 2016. I'm not changing it. I'm keeping that to 2 vCPUs and 8 GB of memory. Review and create. Let's see if we can create it in this region. So the validation is passed because we have given only 2 cores for this machine, and then we have given 2 cores or resized the other machine which we have created. So for this region, for your license, it is only 4 cores which you are allowed to create. So you can increase the core limit by calling Microsoft support and asking them to increase the core limit for your region, for your license. So let's go back to virtual machines, LB1. Let me connect to that virtual machine again. So what we'll do on this machine, we'll try to install a simple IIS role and just try to configure this as server 1, right? Let me try to install a role on this. Add role. Next, next, then next. I'll be installing a IS role, that is web server role. And install. In the meanwhile, let's go to the other virtual machine and see if it is created. Okay, so this is created. Let's try to install the web role in that machine as well. I just installed two virtual machines and I've created them in a same availability set in the same region. And then I'm trying to connect them to a load balancer and check how the load balancing works, right? So let's go to server manager of this machine as well. And then add role. Click next, 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 and click on web server role, add features, next, just the default options, next, and install. So I'm just trying to install the web server role on both the machines. Feature installation succeeded. So close this. Let's wait for the other machine also to complete with the installation. Just give me a minute, guys. I'll be right back. Yeah, so the feature installation is completed on this two machines. So let's go to this machine and get the IP address of this, run cmd, and then go to ipconfig. So this machine is 10.1.0.7 and this is our load balancer VM2. And what's the other machine's IP? This is cmd IP config. So this 10.1.0.6. So what am I going to do is I'll go to this web server HTM, that is, it will be in C init pub and www root, and we do have a HTML file, right? So we do have a file. So what I'll do, I'll try to create a new text file, and that hello, and then I'll say this page is served from web server 1, right? Web server 1, and then I'll say I'll close this. I'll save this. I'll close this. I'll make this the extension of .html. Or else what I'll do, I'll try to copy this. I'll try to paste this in the notepad, and I'll save this. Okay. So once you open this, this says that the page is served from web server 1. So I'll try to delete this. So if you go to this local server and say localhost, and it says that the page is served from web server 1, right? So this is configured first server. So let's go to the second server and do the same thing. So let's go to C drive, init pub, www root, and I'll try to modify this with notepad. And then what I'll do, I'll copy that and I'll say this page is served from web server 2, right? So I'll save this. So if I go to the local host of this machine, it says the page is served from web server 2, right? Are we clear, guys? So what we have done, so we just have created a IIS server and we just have edited this HTML file saying that just to see from where the file is served, right? So if we do the same thing from here, so if I go to this server and if I copy this and if I paste this here, I should get the same kind of response. From VM1, let's try to copy this and let's see if we are able to get the same kind of response here. We are not getting the response because it is tied to the internal IP address. So let's go to this web server and this is web server 2. So now let's go ahead and try to add these two machines to a load balancer. Okay, Let's go to Home tab. Let's go to Load Balancer, LB1. And now what we have to do is, this is having a public IP address, that is front end pool IP address. This is the Load Balancer IP. So if I go here, choose a public IP and save. And backend pool. Backend pool is the one which we have to use now in order to add the servers. Let's try to add the servers. Backend pool name is test load balance, and then I'll try to add the virtual network. What is the virtual network which we are using on that? Let's go back and check. Virtual machines. Let's go back to check where these virtual machines are deployed. So this is deployed to test SNIT-VNet. Let's go to load balancer. Try to create the backend pool. Backend pool name test load balance, and then virtual network. Why is it not giving test SNIT? Okay, so I think I have created this in a different VNet. Let's try to create a new load balancer and resource group. I'll try to create it in test SNIT, and then I'll say load balance 2. East US 2 is where our virtual machines are, and it will be a public load balancer basic. Create a new IP, and then it will be PIP LB2, and I'll say dynamic. So next, review and create. So I'm trying to create two virtual machines. I made them a web servers. Now I'm trying to attach them to the load balancer. Okay, this is done. Let's go to load balancers. So let's go to load balancers. So we got a NAT rule, and we got a public IP, PIP IB2, and let's try to add the backend pool. Pool name test load balance, and then the virtual network test SNIT VNet, then virtual machines, and then I'll see the LBVM1 IP address, that is 106, LBVM2, that is 07. So these are the IP addresses, guys. Why we are not able to add these machines in LB1? Because LB1 is created in East US, not in East US 2. But we have created these two VMs in East US 2 today. So that's the reason we have to create the LB2 load balancer, which is in the same location, that is East US 2. Click OK. Let it create add the backend pool. So in the backend pool, we can add a lot of virtual machines, right? So it's not just two. but we can add up to 10 or 15 virtual machines as well, depending upon the SKU size of the load balancer. So it can serve the request accordingly. For now, we just have added 2 virtual machines as a test purpose. I don't see Vishnu. Oh, Harsha is, did he disconnected or?
Yeah, actually, he was in office, sir.
Okay,
So that he was disconnected. He called me.
okay. So once this backend pool is added, guys, so we'll try to create a health probe and a load balancing rule. I'm still trying to create. So test load balancer 2, and we have 2 virtual machines added in here. So let's go to load balancing rule and try to add a load balancing rule. Front end IP. Let me check why it is not giving us the front end IP. Save. Then let's try to create a new load balancing rule. Let's go to create a new probe and then try to create a probe name, that is test probe, and then TCP and 80. And if for 5 seconds, if it is not responding, the first server, for 2 consecutive times, that is 10 seconds, if the first server is not responsive, then it can take the responses from the second server. That is the rule which we are trying to create here. So the probe is created. So the test probe is successfully created. So backend pool is created, health probe is created. Let's go and try to add a load balancing rule. Still getting updated. There's something wrong with this. Let me try to refresh this and load balancing rule. Try to add this So now we are able to see the rule which we are going to add. So let's say we'll add test rule, and then IP version 4 front end IP, and a TCP port, backend port is TCP, test load balancer pool. So the backend pool which we have added, session persistence none, that should be fine. Click OK. It's okay. Let's try to create a new role, new load balancing rule. So the new load balancing rule has been attached now. So a public IP is seen now, right? So if we try to access this public IP, what happens? So let's try to access through this public IP. Let's copy this IP. Then load balancing rule is created. Let's see what's this load balancing rule is. And then TCP 80 port 80 backend pool we have created TCP health probe 80 and then updated. Okay, and overview load balancing rule is saved. Try to copy this. Not serving the request. Yes. Let me check on this, guys. Why it is not responding? I'll try to check on how why this is where we are missing it, and I'll try to fix that, and I'll show you how we can do this. But load balancer, when once this configuration is done with the public IP address, it should be able to show the internal server which is generating the request. Let's say if the request is generated from server 1, if the server 1 is down, then if you try to refresh the server, it should be generating the request or giving the request from server 2. Okay, so that is about load balancer. Let's go back. So we discussed about load balancer. If two VMs are in this in connected to this load balancer, if there is a disconnect from the VM1, it will try to connect from VM2. So we discussed about internal load balancers, DNS. Azure DNS is nothing but you can host your DNS servers on Azure as well. and traffic manager. Traffic manager is the one which routes the traffic to the nearest location. In the sense, let's say you have websites all over the world, right? Let's say you have it in Europe, you have it in US, and you have it in India as well. In those cases, if a request is coming from Europe, it will try to route to the Europe's web servers. And if the request is coming from US servers, it will try to route it to US servers. That's the use of a traffic manager. So security group. What are security groups? Allows you to filter network traffic through the Azure resources in the Azure virtual network. So if you try to create a network security group, you can define what ports to allow and what ports not to allow, right? So if you create an NSG, and you can define in that, let's say port 80, whether it is allowed or not, port 3389, whether it is allowed or not. So we can define that in the network security group. So this is how the incoming traffic can be allowed or denied through the network security group rules. Network security group rules, security group. So application security group. So let's go back to the portal and try to check on the security group rules. NSG, network security group. Let's try to create a new NSG. I think these NSGs are already created. Let's go back to the virtual machines and see if there is any NSG created here. Networking. So let's try to add a port group or allow a port which is 80 here. So if you want to allow a 80 port, let's see how we can do it. Custom port number 80, and then the priority is nothing but, let's say if you give priority 100, that could be your topmost priority. Let's say if you give priority 200, that will overwrite let's say 200, that will be lesser than 100. So if you have given a 200 rule to allow a particular port 80, and if you have given a 150 rule number to deny that, so 150 will be having a upper hand. That means either the lesser the port number priority, the more the weightage. So let's say I'll give 101 for this, so that it will be powerful. Description, add. Let's try to add this. This is incoming ports, inbound traffic. For inbound ports, 80 is allowed now. So let's try to add the same thing in outbound basic custom HTTP and 80. I'm going to give 101 port 80 and then port 81 add. In the inbound traffic as well, we'll try to add a basic HTTP 80, and then I'll try to add this as 11109. Okay, click on add. So what I have done is I have allowed port number 80 to these virtual machines with the NSG. So in the network security group. So this is the NSG rules, the priority, whatever the ports allowed. So you see, whenever we try to create a virtual machine, always we allow this RDP port, that is 3389, or else we may not be able to connect to this virtual machine. That's how we can create inbound security rules and outbound security rules. Inbound security rules are nothing but whenever we try to access the server through a particular port, that port should be open, right? So whatever the incoming traffic. Outbound is like I'm trying to reach something and I'm not able to reach anything. So in that cases, I have to open that port from my machine. As we created this network security groups, let's go ahead and try to access with this particular IP and see if it is working. You see this? So before creating or allowing those web ports, port 80, I'm not able to access the web servers. But now I'm able to access the web servers. Let's go back and try to do the same on VM2 because the required ports, that is port number 80, is blocked on both the NSGs. So let's try to add a basic port, that is HTTP, and try to give the priority of 120 port 80. So now we got this. Why we are not able to access those web servers? Because the ports are blocked. When we try to add these inbound and outbound ports on the NSGs for these machines, we are able to see the web server requests. So let's go to outbound port rules as well. Try to create a basic HTTP port 130, and then let's try to create a row name and okay. Okay, and inbound, let me try to create a HTTP as well for this 180, and I'll say okay. So let's see if I can go ahead and access with this IP address now. Okay, so now the request is being served from web server 1. Is that correct? Guys, this is important. So are we on the same page? The request now is served from server 1, right? So we have attached both the virtual machines to load balancer, and the load balancer is serving the request from web server 1. Let's go ahead and stop web server 1 and see what happens. Okay, are we getting it? Let's go ahead and stop web server 1 and see what kind of requests we are getting. Web server 1, let's go ahead and stop it. Stop web server 1. So web server 1 may not be able to serve those requests now. So let's see if your load balancer is able to pick that from web server 2. Let's refresh. You see this? So whereas the web server 1 is down, you can see the requests are served from web server 2. This is the reason why we have edited those internal files, that is log IIS-HTM files, in order to see the difference between the two servers or from which server the request is being served, right? So this is how a load balancer works, and also how we can configure a network security port rules, right? So let's go back, and force tunneling is nothing but if you want to force all the network traffic to be going through the on-prem firewall instead of going through the Azure to internet, we'll try to do a force tunneling so that traffic, Azure traffic also goes to on-prem and then leaves from on-prem to outer network. User defined rules and application gateway, as load balancer is for web servers to serve the request. This is for websites to route the traffic in a proper way by seeing the type of requests. Application gateway, this is how the application gateway is configured. So this, the load balancer is at the top, a DNS traffic manager is at the top. It comes to the load balancer, and from there it goes to the application gateways and then to the virtual machines. This is how the topology is. Network appliance. So network appliance is just for connecting or just for doing firewall or security rules. So it's a third-party appliance which can be installed. Azure DDoS protection. So if your network is flooded with the traffic, with the same kind of traffic, in the sense identical traffic, so that is called as a DDoS attack. So what they want to do is they want to flood your network, and they want to spoof into your network to sniff the packets. In that case, what we will do is we'll try to enable network DDoS protection in order to sniff each and every packet and discard the identical packets so that the network will not be choked, right? So DDoS protection tiers, there are basic and standard, two types of tiering. DDoS protection testing. So there'll be each packet, if there is a identity, if there is identity between these two packets, then they'll be sniffed accordingly. In the sense, they'll be taken to a different route, and then they'll be checked, and then they'll be processed. So DDoS metrics. Azure firewall, like NSGs, you can also create Azure firewall and say that which ports to be allowed, which ports to be blocked. It's like normal firewall which you used in your on-premises. So these are the features built in high availability. So load balancing is an option, and it can limit the HTTPS traffic to a fully qualified domain. So these are some of the options of Azure firewall. Again, network watcher is used to sniff the packets between the machines and in the network. If you, it's like Wireshark, right? With Wireshark, you do a lot of packet analysis, like saying that if two virtual machines are not pinging, then you can sniff the packets between these two machines, and then you can troubleshoot further. In the same way, network watcher also sniffs the packet between 2 points, that is virtual machine 1 and virtual machine 2. If you want to do a testing between these two machines, you can do through connection monitor. So network watcher capabilities, topology, you can check the topology, how the machines are installed within a network. IP flow verify, check if a packet is allowed or denied on based on the flow verification. So if a particular port is blocking, then you can go ahead and check it in the network watcher, which port is blocking and where it is blocked. Next hop determines the next hop for packet being routed in Azure Network Fabric. So through which route the packets are being routed, or what is the next hop it is taking, you can check from this network watcher. Effective security rules, what are the security rules applied, and which ports are blocked, which are not blocked, and which are to be open, you can check from here. Packet capture, you can capture the packets between these between the machines, and then you can analyze them for troubleshooting purpose. Connection troubleshooting, if there is no ping or if there is no connectivity between the two machines or any other machines in the network, you can do a troubleshooting between these two networks. NSG flow logs capture logs related to traffic that is allowed or denied by security rules. So when you create an NSG, let's say by mistake you created a rule which blocks all the traffic. So you can go to this Azure Network Watcher and check how we can open those ports, or how we can troubleshoot that. So that is about networking, guys. So today we have completed Azure Load Balancer and Azure Network Watcher and different components in that. 1 second. Let me open this portal thing. So I'll try to stop the recording.